Before we go too much further into the course, let's quickly talk about rounding and how to avoid some rounding errors. We've got a combat scene here where damage is being taken, damage is being dealt, and you can see that the values are being rounded. However, you may also notice that values aren't being rounded quite the way you might expect. So we're probably already familiar with the traditional way that we round a number, where say we have a number 2.73, for example, and we want to round that to one decimal place. Well, we look at the next number after our cutoff, and we say that if that number is greater than or equal to 5, then the number before it is increased by 1. And if it's less than 5, then we just leave that number as is. So 2.73 would be rounded to 2.7. Or if we were going to the nearest whole number, then the 7 is greater than 5, so the 2.7 would round to 3. Nice and simple. One thing to watch out for is when the number that needs to change is a 9. Let's take an extreme example of 9.99 and try rounding that to one decimal place. Well, this would cause this 9 here to equal 10. However, we can't just put 10 in that column, so we need to put in a 0 and carry the 1. We then move over to the next number and we add that one we've carried, and that would give us 10 again. And so in this example, 9.99 would round to 10.0. It's important to note that whenever you need to give an answer to a certain level of precision, in this case one decimal place, you need to keep those extra digits in there, even if they are just zeros. So in this case, the answer is 10.0 and not just 10. It seems quite pedantic, but it can become important in certain circumstances, so it's worth remembering. Another option would be to take something called the floor of a number, and what this essentially does is always rounds the number down to the nearest whole integer. So regardless of what decimal places we have, we essentially ignore them and round down. So in our example of 2.73 over here, the floor would be 2. The opposite of this would be something called the ceiling of a number. And what this does is always rounds the number up. So again, with our example of 2.73, this would round up to 3 like it would normally. But if we had another number, say 3.2, this would round up to 4. And for the eagle-eyed among you, you may notice that that was what was actually happening in that combat clip at the start of the video. So why do we care about all of this? Why don't we just round normally and be done with it? Well, let's say we have an enemy who's attacking our player. This enemy is very weak compared to our player and only manages to inflict 0.62 points of damage after some other modifiers have been added to it. If we choose to round normally, then this would do 1 point of damage, but if it were any weaker, then it would probably do none at all. Or we could choose to be generous to our player and take the floor of the number. In essence, we're saying that the damage is always rounded in the player's favour, and in this case, it would do no damage at all. Or we could do the opposite and be a little more harsh and always round the damage up. By taking the ceiling of the number, an enemy will always be able to inflict some small amount of damage, no matter how weak it is in comparison to our player. And this means that even the lowest level monster can kill our hero if they're on their absolute last legs. With all that said, one thing to note at this point is that whenever you're doing a calculation of any kind, you should always perform the rounding last. Otherwise, you can start to introduce small errors and they compound over time. For example, let's take 5.1 times 4.7 and then add 2.5 to that. If we do that sum, then it gives us 26.47, and if we round that, then we get 26. However, if we round those numbers first, say some function is returning a rounded version of the calculation, we get 5 times 5 plus 3, and that equals 28. And as you can see, the end results are quite different. So be very cautious when you're doing these sorts of things to make sure these errors don't stack up over time, because this can lead to all sorts of weird and wonderful and unexpected behaviours in your game. With all of that out of the way, let's look at how we might implement this in code. Most modern languages have some sort of math library that you can access, and the syntax is fairly similar between each one. So for rounding, we can use math.round, and then in the parentheses, you'd include the number you want to round and the level of precision that you're looking for. So this would be, say, 1 for 1 decimal place or 5 for 5 decimal places, etc. The floor and the ceiling are very similar to this, except we don't need to specify any level of precision since we're always just rounding to the nearest whole number. So we have math.floor passing in our number, and we have math.ceil passing in our number. Notice though that the method for ceiling has been abbreviated to ceil here, C-E-I-L, and that's usually the case across the board, so it's worth keeping in mind. Okay, so hopefully that clears up how rounding works and how to avoid some of the common pitfalls you might come across. We haven't covered rounding with significant figures yet, but we'll cover that when we get onto scientific notation. Finally, it's time for your challenge. So I'd like you to take the number 6.283 and I'd like you to find the floor of this number. I'd also like you to find the ceiling of the number, and I'd like you to find the number to 1 and 2 decimal places. So once you've got your answer, pop it in the community forum and I'll see you in the next lecture.